The transition to modern artificial intelligence is rarely about replacing an entire job. Instead, the software fluidly crosses traditional organizational boundaries, performing tasks that used to require a handoff between different departments. While early models functioned as chatbots, systems waiting for a user to enter a prompt so they could generate a text response, the current generation of agents operates differently. They execute multi-step work across various applications. This bar chart tracks recent usage data from Perplexity, comparing the duration of a standard human-led search query to an autonomous agent session. On the top bar, a traditional search takes an average of 33 seconds. On the bottom bar, an agentic session runs for an average of 26 minutes. Here, it autonomously breaks a primary objective down into subtasks, sequencing and executing each one. Because the system handles the manual execution of these composite steps, the human operator's role shifts. Instead of clicking buttons and transferring data, the user verifies the output, sets the high-level strategy, and extends the project scope. The defining characteristic of modern knowledge work is no longer the speed at which a person types. It is the ability to manage software that no longer waits for a human prompt to take the next step. This level of autonomy is already actively condensing complex project timelines in real-world enterprise environments. Using traditional search tools, operators required 269 minutes. With autonomous agents, that duration drops steeply to 36 minutes. The financial impact mirrors this speed. This 87% reduction in time directly correlates to an estimated 94% reduction in capital cost. The efficiency comes from bundling. Agents take previously isolated subtasks, like writing code, querying a database, and formatting a report, and combine them into a single, seamless query that draws on broad, cross-disciplinary expertise. By expanding the scope of what a single prompt can achieve and sharply reducing the associated cost, these systems create a significant ROI incentive for enterprise adoption. However, despite the massive potential for high-speed execution, many enterprises are actively engineering barriers to restrict agentic software. This chart visualizes the contradiction found in recent industry surveys. While workplace adoption of AI agents has surged to 59%, 63% of technologists refuse to let these agents operate on full autopilot. Telemetry data from Anthropic reveals a counterintuitive trend in how people manage these systems. As human operators gain more experience working alongside agents, they actually interrupt the software more frequently to provide course corrections rather than letting it run unchecked. The models themselves are also calibrated for restraint. On complex tasks, advanced agents are explicitly trained to pause and ask for clarification more than twice as often as human operators choose to interrupt them. Enterprise AI has settled into a state of engaged collaboration, where human interruption is the primary mechanism ensuring the work remains aligned with organizational goals. In this new environment, the human operator's job description shifts. Instead of executing individual tasks, their primary focus becomes designing the structural boundaries that keep the software in check. Monitored autonomy has emerged as the standard framework for managing modern knowledge work. At the center is the AI model, providing core intelligence. It's wrapped by a restrictive ring called the harness, providing strict guardrails. The agent connects to external nodes, the tools. All components are enclosed within a rigid perimeter, the environment, dictating ultimate security limitations.
Within this structure, operators often utilize states like plan mode. Before taking a single action, the agent must generate a comprehensive, multi-step strategy and present it to the user for review. High-stakes actions require hard-coded human approval gates. The system maintains detailed identity logs and predefined escalation paths to ensure every change to a critical system is verified by a person. The human operator no longer performs the heavy lifting. Instead, they engineer and maintain the highly monitored cage where that heavy lifting can occur safely. Beyond the technical infrastructure, this architecture outlines a long-term strategy for enterprise AI integration. For most businesses, pursuing total, unsupervised autonomy is a goal that contradicts the practical need for oversight and the inherent risks of unmonitored execution. True competitive advantage is derived entirely from precision. Success depends on the ability to seamlessly integrate high-powered, autonomous execution with strict, reliable governance. Market dominance now rests on knowing exactly which agents, are authorized to act, which must ask for clarification, and which must immediately stop.